Hey scholars, I hope you all are doing well today. For today's lesson, we're going to talk about this thing called the natural base, which we will call e, and the natural logarithm, which we will call ln, or I'll say ln probably sometimes during this video. But we're going to use the natural base and the natural logarithm to help us solve some problems, and then we're going to talk about continuously compounded interest. But make sure you're paying close attention, taking good notes. Let's get going. Alright, so we've got a new friend that we're meeting today, and his name is just E. We call him the natural base. And the reason we call him the natural base is because he's just a base. We can take E and raise him to any power. You'll see e to the x. In fact, this is the equation f of x. This is a graph of the equation f of x equals e to the x power. So what e is just an irrational number that you'll see a lot in math and science. It's an irrational number kind of like pi. Pi, is 3.14. It's about 3.14. And it's irrational because really that number keeps repeating. This is just a rounded value of pi. E actually rounds to 2.71828, or you'll often see it as e is about 2.72. Alright, so e is about 2.72, whereas pi is about 3.14. So where did e come from, you might ask? Well, try to follow along with me. If it goes over your head a little bit, it's okay. But just want to refer you to this chart here. So let's say we're taking 1, and then we're adding 1 over 1. Alright, and 1 over 1 is obviously just 1. So 1 plus 1 over 1 is 1 plus 1, which is 2. And then we're saying 2 to the first power. So that's just going to give us 2. Now, we're changing that denominator from 1 to 2 here. So 1 plus 1/2 to the 2 power. We're changing that exponent also to 2. Alright, so when we say 1 plus 1/2, that's 1.5, and then 1.5 squared is 2 1/4, or 2.25. So you can kind of follow this chart. As this chart changes, as this value, that denominator, which is equal to that exponent, you can see that the denominator and the exponent are equal. As that number gets bigger, as it increases, that denominator and that exponent, as it increases and goes to infinity, we arrive at this number, which is about 2.72, and this irrational number is just what we call e. So as that number approaches infinity, we would just call that base, we would call that value e. So anyway, that's our new friend e. Let's meet our other friend ln, or we'll just call ln. Let's move forward. Alright, so the natural logarithm ln. The natural logarithm is a logarithm with base e. So instead of saying log of e, of base e, we would say ln or ln instead. Okay? So this is just another way of writing log base e. Okay? So they have the same properties as any other logarithm. Just the base is e. So you would use the product property, the quotient property, power property, any property of a logarithm that you have, you can use with ln. Okay? So the natural logarithm function, which is f of x equals ln of x, is the inverse of the natural exponential function f of x equals e to the x. So basically all this is saying is that the log of e, log base e, which is ln, is just the inverse of e to any power. Okay? So check this out. We can use the inverse properties that we've seen with logarithms. We can use that with e and ln. So e raised to the ln x power equals x. So for example, we're saying e to the log base e of x. That's what ln is, right? It's log base e. And so inverse property here, that's just going to give us x. Or ln of e to the x power equals x. So think about it like this. This is an inverse property that we've talked about before. We're saying, instead of ln, we can say log base e of e to the x power. Well, you know, inverse property, those are going to cancel out, and you'll just be left with x. Okay? So we're going to use e and ln throughout this lesson, so I just want to try to give us a little basic understanding of these before we work some problems. If you feel a little overwhelmed, I think it's about to get a little bit easier as we move forward. So now let's try some problems. Here we've got ln of e to the negative 2t power. So here's the deal. Remember, ln and e, the natural log and the natural base, they're just inverses. So all that's going to leave us with is negative 2t. Remember, using that inverse property, remember, instead of ln, we can say log base e of e to the negative 2t. Well, inverse property, all that's just going to end up canceling out. You're just going to be left with negative 2t. Okay, so now let's look at number 2. E to the natural log, or ln, right, the natural logarithm, t minus 1. Well, inverse properties, natural base and natural log, they're going to undo each other, and all you're going to be left with is t minus 1. And number 3, this one's going to be a little bit different. We've got e raised to the 5 ln x, or natural log of x. So we got that 5 in the way. We didn't have a number in between the e and the natural log before. But this 5 right here is in the way. We need to get rid of it. Well, remember, this is a logarithm. This is the natural logarithm. So it has all the properties of any logarithm. So what we can do is move that 5. Since that 5's in the front, we can move it here and make it an exponent of x. So we're going to end up with e to the ln of x to the 5th power, or natural log of x to the 5th power. See how I moved that 5 into the exponent there? Remember, that's the reverse of the power property that we've talked about before. So now I've gotten that 5 out of the way. It was blocking me from being able to do anything, but now we've gotten it out of the way. So what's going to happen now? That's right. The e and ln are going to end up canceling out, and we're just left with x to the 5th. We're going to end up applying some of these properties as we work some problems moving forward. Follow along with me. Now you will need your calculators for this part. You should hopefully have a graphing calculator. So what we're going to talk about now is continuously compounded interest. We talked about compound interest last week. Now we're going to talk about continuously compounded interest. So when interest is compounded continuously, we use this formula. It looks a little messy here. I'm going to write it without all this stuff in the way. It's A equals P times E to the RT power. It looks like PERT. PERT. A equals PERT. This should be an easy formula for you to memorize. Is all we're saying is PERT. Okay? So when you see continuously compound interest, we're going to use the formula PERT. Now, the key word here is continuously. See how it's in bold? Last week we talked about when interest was compounded annually or weekly or daily or quarterly, whatever. So we're not going to use the PERT formula. We're going to use the formula that you learned then. It was, I believe, A of t equals A times 1 plus R over N to the NT power. Okay? So that was the formula we learned last week. Now, we can, instead of A, we could say A of t. Okay? But regardless, this just means the final amount after a certain amount of time, right? So, check this out. This is laid out for you. You got the final amount equals the principal, P, so the initial value, the principal, times E, the natural base, okay? So E raised to the rate of interest, whatever your rate of interest is, times time, okay? So this, the rate and the time, R times T, that's going to combine to become one exponent. The rate times the time will be one exponent, the exponent of the natural base, which is e, right? So just be careful here. Don't get this confused with compound interest. Remember, that was the formula for compound interest. You have a new formula for continuously compound interest, but again, shouldn't be too hard for you. It's PERT. So let's work a couple problems applying this PERT formula. So let's try this. This asks, what is the total amount for an investment of $1,000 invested at 5% for 10 years, compounded, what's that word? Continuously. That's right. All right, keyword is continuously. So when you see continuously, what formula does that tell you you're going to use? That's right, PERT. A equals P times E to the RT power. All right, so we're trying to find the total amount. So A is what we're trying to find. So we're going to say A equals 1,000. So that's the principal, right? The principal is 1,000, so times E. Now let's figure out what R and T are. The rate is 5%, right? So we need to convert that to a decimal. That means R, we're going to move that decimal place 2 times. So 0.05. Remember, if you don't convert to a decimal properly, you're going to throw off this entire problem, okay? So 0.05 is our rate, and then the amount of time is 10 years. So we're going to say T equals 10, okay? So 0.05 is R, so I'm going to substitute 0.05 for R, and then 10 is the time. It's the number of years. So 0.05 times 10. So we get A equals 1,000 times E. And then 0.05 times 10, well, that's 0.5. E to the 0.5 power. We can say 0.5 if you like. So now let's put that in our calculators. Follow along with me. I'm going to show you how to put it in your calculator. We're going to say 1,000 then times E. So I'm going to hit, let's see, second ln. You see that ln button here? You may have always wondered, what does ln mean? ln. All right, so we're going to hit second ln, and you see how that's going to give us e to the x power? All right, so then for that power, I'm going to say 0.5. All right, so e to the 0.5 power. I'm going to hit enter. And this is money, right? So we're going to round this to the nearest cent. This is going to be, final amount is going to be $1,648 and rounds to 72 cents. All right, so for this one, we just plugged and chugged into our formula. That's all we needed to do. Let's try one that's going to be a little tougher, where we're not just finding the final amount. So this one says Fiona wants to double her money. She put $4,000 in a bank account that pays 3% compounded continuously. How many years will it take for her to double her money? Okay, let's think about what we have. We see continuously, right? Compounded continuously. So we know we're going to use PERT. So let's just go ahead and write that formula. A equals P times E raised to the RT power. All right, so let's figure out what we know. She wants to double her money, and she put $4,000 in a bank account. So $4,000 is the initial amount. That's the principal. So we know P. So we've got P is 4,000. I'll just write that over here. P is 4,000. And 3% is the rate. So R equals, remember to convert that to a decimal. Move that decimal place 2 times over. That's going to be 0.03. Now, the time is what we're trying to find, right? We don't know the time. So that's what we're trying to figure out. Do we know A? Well, what is the final amount? Well, what are we looking for? We're trying to figure out how long it takes for her to double her money. How much is double her money? Well, that's 4,000 times 2, right? So $8,000. We're trying to figure out how long it takes for her to get $8,000. That's the final amount. So A, we know A equals 8,000. So I'm going to say this. I'm going to substitute this in here. 8,000, which is A. 8,000 equals 4,000 raised to the 0.03 t times t. 0.03 times t. R times t. All right. Well, how are we going to do this? Oh, be careful. Don't do what I just did. I forgot to say e. 4,000 times e to the 0.03 t. So be careful there. Don't do what I just did. So we've got 4,000 times e to the 0.03 t. All right. So now let's try to isolate t. What I'm going to do first is I'm going to divide both sides by 4,000. Divide by 4,000. Because we've got, this says 4,000 times e to the 0.03 t. So I'm just going to get rid of the 4,000. And 8,000 divided by 4,000 is 2. So we get 2 equals e to the 0.03 t. All right. Now, here's the thing. We're going to put it all together right here. We're trying to get rid of t. We're trying to get rid of everything but t. We're trying to isolate t. So, how can we get rid of e? Well, remember, we're going to take the natural log of both sides. We're going to say ln of 2 equals ln e, because the natural log and the natural base, they are inverses, right? So what's going to happen here? We're going to have the natural log of 2 equals, what's going to happen here? Well, these inverse, right? We're just going to be left with 0.03 t. And at this point, to isolate t, we're just going to divide by 0.03. So we cross out, cancel that out, we get t equals ln 2 over 0.03. I'll write the final answer over here. I'm going to put this in the calculator first, though. We'll say ln, do that closer, ln 2 divided by 0.03 equals. All right, so t, the amount of time, and we'll round it to the nearest tenth here. How about that? 23.1, and then what was the unit? How many years, right? 23.1 years. That's the amount of time it will take Fiona to double her money, to go from $4,000 to $8,000. So I hope this video was helpful for you. If you need to rewatch any parts of it, I highly recommend you do that so that you're prepared for class. But I'll see you in class. Good work today. Thank you, Collegiate Scholars.